In the preceding video I showed this small electronic candle, and my second idea was how can I amplify this effect in such a way that a bigger lamp follows the light variations from this small candle lamp. And here we also use the Darlington, and I made a light sensitive lamp. It's in fact very easy to understand. When the base is made positive, the Darlington gets in conduction, it acts as a switch more or less, and the 6-volt bicycle lamp lights up. And we make the base positive by changing the resistor value from this LDR, and this LDR reacts on light. When it's light, it is in full bright light, it's approximately 50 ohms, and when it's dark it is 500k or higher. And with this resistor here we have a voltage divider at the node here, and we can pull the base down to the negative. That means that we can also make the base negative, and the transistor circuit pinches off and the lamp stops. And that means also that we can set the sensitivity here. So the first funny thing from this circuit is that when the light switches off, the bicycle lamp also switches off. So it amplifies more or less the effect from the light. And now I want to demonstrate what happens when we have a small light source here, this generator, more or less close to the LDR, the light dependent resistor. Now we can see that the lamp follows the variations, the bicycle lamp follows the variations from the light that's generated by the LED. You can see that it's very sensitive. You can also see the extreme sensitivity from the circuit and also the sensitivity from the LDR. And we can set the effect by this potentiometer here, this potentiometer. I want to demonstrate that now. We're going to set it to more and less sensitive. Now there's no effect. Now you can see very slow, very low effect. The lamp glows a little bit and it gets more and more high. But of course at the same time the light rays are entering the LDR, and that means that the circuit gets in a sort of circular mode, and the lamp is activated by the lamp itself. So that's not our aim. So we set the sensitivity back, and then we can see that the variations are followed. So perhaps this is an interesting circuit to use in some application or so, and it also demonstrates the extreme good amplifying properties from the Darlington circuit.